Hello and welcome to a video on Pythagoras theorem and TOA. So I'm going to explain what that all means. Quite simply, you might already know, again we have to rely on my rubbish drawings, but there we are. You might already know that, let's say these are labelled ABC, and you might already know that c squared is equal to a squared plus b squared. And so here we have a right angle triangle, 90 degrees, or pi by 2 radians. So hopefully you're aware of that. So if we put that into practice, let's say we had, let's say this is 4, let's say this is 3, let's say that is 5. So we would have, sorry, I've given the game away already. You don't know that's 5 yet. So that's c. So c squared is equal to 3 squared plus 4 squared, which is equal to 9 plus 16, which is equal to 25. So if we were to say c squared is equal to 25, we'd take the square root of each and we would be left with c is equal to 5. So therefore that would be 5, and you didn't know that until I just did it for you. So that's how that would work. But we're going to delve a little bit deeper, especially in the next couple of videos. And you might end up with a right angled triangle, if I can draw one. Let's say you're asked to find this, but you're given one side length and you're given the size of an angle. So you might be asked to find that. There may be another one whereby you're asked to find an angle given 2 side lengths, for example. So this is, and I didn't do that very well either. Not a good day today. Never mind. There's supposed to be a theta symbol. So we identify angles by theta. So this would introduce then the concept of trig ratios. So let's say, let's draw another one out. You'd think I'd be good at it by now, but apparently not. So let's say that this is the angle we're looking for. The side opposite this angle is quite simply known as the opposite side. The side next to this angle is known as the adjacent side, and then this is the hypotenuse, the longest side. So here's where trig ratios come in. So let's say you'd have sine theta is equal to opposite over hypotenuse. You would have cosine theta is equal to adjacent over hypotenuse, and then you'd have tan theta is equal to opposite over adjacent. So what this means is that if you're given a side length and an angle, you can use those details to find another side length, or if you're given 2 side lengths and trying to find an angle, this is what we'd do. So the reason why it's called SOH, you can see here sine opposite hypotenuse, SOH, CAH, and then TOA, SOH. So that's what we would use there. So in the next couple of videos, we'll actually put this into practice and see how that plays out, and we'll be looking for, we'll be looking to identify angles or side lengths, and we'd use these formulas here. So that's a little bit of an overview of just going a little bit deeper into Pythagoras theorem. Give you a brief example to begin with, and then just you might find a little bit more complex questions looking for a side length given an angle, or looking for an angle given 2 side lengths, let's say. And this is what we would do. So please look out for the next videos where we'll practice this and go through some examples. Please do like, comment and subscribe. That really helps me out as I try and grow this channel and try and get better at delivering this stuff. But yeah, thanks for watching, and I shall see you on the next one. Take care.